kind of on a roll right now. We're going to quote section number 2 of chapter 13. We're going to talk about hyperbolas in this one. Hopefully the sun will stay away for this one. Looks like it's clouded up a little bit, so might not get smacked in the face with the sun this time. We'll see what happens. So we're going to do with hyperbolas today. We're going to recognize equations of hyperbolas and graph hyperbolas using what we call asymptotes. It's all going to sound confusing, but here's kind of the nice thing about it. If you could do the ellipses, you're going to be able to do these, and we'll show you how. Okay, so first thing we want to be able to do is recognize the equation of a hyperbola. So hyperbola is a set of all points in a plane such that its absolute value of the difference of the distances, blah, 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 called the focus constant, okay? So here are our standard forms for a hyperbola. And you need to get these into your notes, but we're going to change it up a little bit just like we did before. So there are two different forms that you can have for this. You can have x minus h squared over a squared minus y minus k squared over b squared equals 1. Now, when you have that, your hyperbola is going to kind of look like an x. It's going to kind of look like that. Hyperbolas are kind of two parabolas that are facing away from each other. That's what a hyperbola is. And when it's in that form, when the x comes first, when it's x minus y, it's going to look like an x. The other type that you can have is y squared. So we're going to go y minus k squared over whatever. Some books put a squared here, some put b squared. It doesn't really matter. Minus x minus h squared over a squared is equal to 1. So the y is going to come first, and there's a couple things you have to be careful with the y. Well, first, it looks like a y. So anytime you have the y first, it goes y squared minus x squared. It's going to look like a y and an upside down y. Okay, that's what the hyperbola is going to look like. The other thing you have to be careful with, the center of both of these is hk. The center of this one is still hk, but notice that it's y minus k. So when you're doing this, you need to be aware that when that comes first, you need to be aware that you need to put the k in the y value of your center, not in the x value of the center. It's got to go in the y value of the center, and it's a common error. And the h one obviously then needs to go in your h. Kind of what I say is, if it's y minus, it goes in the y spot of the center. If it's x minus or x plus, it goes into the x part of the center. So you have to be very careful with those when you're doing these problems. So we're going to graph. It's all of this fun stuff using asymptotes. We're just going to go ahead and do this. Okay, so let's look at an example. So we've got x squared over 81 minus y squared over 64 equals 1, and we're asked to graph it. So right away, x comes first. So right away, I know my graph is going to look kind of like an x. It's going to look like that. Since it's going to look like that, if I'm doing a multiple choice type of situation, process of elimination is probably going to eliminate at least 2 of them. I mean, you know it's got to look like that. And I just look at your answers, and if all 3 of them eliminate and there's only one that looks like that, just put that. You don't need to really know the rest of it. You just need to know the basic concept of if the x comes first, it looks like an x. Okay, so now you kind of got that out of the way. There's maybe a couple of them that look like this. How do we distinguish what it looks like? Well, we find the center. The center of this is just 0, 0. Okay, so if I'm going to graph this, there's my graph. That center is at 0, 0. Sun came out, didn't make it, all but 4 minutes. My a squared value is going to be 81. So my a value is equal to plus or minus 9. So that means because it's underneath the x, I'm going to move 9 units in both directions, left and right. And I'm going to put dots. Okay, and we could name those coordinates if we needed to. We don't need to. B squared is equal to 64. So my b value is plus or minus 8. So from my center, I'm going to go up 8 and I'm going to go down 8. Now, if we were just doing an ellipse, we would just do this thing, but we don't do that with hyperbolas. With hyperbolas, what you're going to do, and this kind of, it's kind of the cheating way to do it, but it works. you're going to go ahead and draw vertical lines through your X points, and you're going to draw horizontal lines. I missed. You're going to draw horizontal lines through those. And then what you're going to do is you're going to draw a diagonal line that goes from corner through center through corner, corner through center through corner. Now, I haven't drawn this very well, but so I apologize for that because it's going to go off the page. But then those are what are called your asymptote lines. Your asymptote lines, if you remember, are lines that your graph approaches, but it never touches. So our graph's not going to touch that. So what's going to happen with this graph is this graph is going to start up on this asymptote line. It's going to come down and it's going to go through that vertice, and it's going to go down like that. And then it's also going to do it over here, but I ran out of room. So it does it in kind of both locations. So you can see that it's going out from each other. If you squished them together, it would kind of look like an X, and it's kind of this pretty wide thing. But that's what that one's going to look like. And again, use process of elimination when you are doing your assignment for today. Because a lot of times you can just really eliminate some of these as you're going along. Okay. There's their A value. They did a whole bunch of different stuff, but you can see that really they did the same thing, and that's what their graph is going to look like. Okay. So let's look at this one. Okay, so now notice it's y squared minus 4 minus x squared minus 25 equals 1. So right away, just my little sketch, I know it's got to look like that. And again, if you can use process of elimination, use it. If that's the only answer, there's only one answer that looks like that, you're done. Hit it, move on. But you should probably know how to do it. Center, 0, 0. Okay, so I'm going to graph this one, make this one a bit smaller. So center is at 0, 0. A squared is equal to 4, or a squared is 25, I guess. So a is equal to plus or minus 5. So the x is underneath my a. So I'm going to move 5 units to the left and 5 units to the right, and I'm going to put dots. B squared is equal to 4. So b is equal to plus or minus 2. So I'm going to go 2 and 2. And we're going to draw horizontal and vertical lines through those points. I'm going to draw a diagonal line through the corners and through the center, through the corners and through the center, and then draw our graph. It's going to look like a Y. It's going to start here, go through there, and up through there, here, here, and here. Now understand, the only part of this graph is really just the yellow. That's it. The rest of it's just to kind of help us draw it. Okay, so really the only answer here is the yellow graph that's sitting right there. Okay. And really that's what we're going to do. Obviously we're going to add things to X's and Y's, but they all really kind of come out to be the same thing. Here's their explanation for it. They've got all these points. It's kind of what we looked at. Okay. We're not going to do this. We're just going to use this as kind of our page to do examples. We're going to do 2 more. So let's go x minus 1 squared over 4 minus y plus 2 squared over 9 is equal to 1. Sun came out again. Okay, so the x squared comes first again. So process of elimination. X comes first, so we know it needs to look like an X. So eliminate the ones that can be eliminated if you're doing multiple guess. Center, it's the opposite of what we see, just like with everything else. So our center is going to be 1 and negative 2. So I'm going to put a dot at 1 and negative 2. Close enough. A squared, whatever, is 4. So my A value is moving plus or minus 2. The A and the B aren't very important in this. Which one's A, which one's B really isn't too important with what we're doing. Just understand that it's underneath the X value, so that means my X value needs to move 2 and 2. So somewhere right there, somewhere right there. My B squared is equal to 9, so B is equal to plus or minus 3. So somewhere there, somewhere there. Again, draw your horizontal and vertical lines through those points. Draw your diagonal. I missed it big time. Pretend I hit it. And it looks like an X, because X comes first. So it's going to start up here, go through there, look like that. And again, the only thing that is my graph is the one that is in black. Is not the other one. Okay. One last one. Okay. Let's go with y minus 3 squared. Nope. Minus x plus 3 squared over 9 is equal to 1. It has to equal 1. It's subtracted. We know it's an ellipse. And we'll do this one together because we're getting to about the 12-minute mark. So our center, and this is one you have to be careful on. You have to be careful on because this is my k value. So my x value is going to be 3. My y value is going to be 3, sorry. My x value is going to be -3. So just be aware of that little thing. The graph itself we know is going to look like a y because the y comes first. So we're at -3, 3, we put a dot. A squared is equal to 9, so a is equal to plus or minus 3. It's along it's underneath the x, so my x is going to go 3 and 3. There's nothing underneath the y, so b squared is equal to 1, so b is equal to plus or minus 1. So the b value is going down 1 and 1. Draw our nice fancy lines. Draw our diagonal. It looks like a y. So our graph is going to look something like those green. And you're done. That, my friends, is graphing hyperbolas, or hyperbolas, depending on how you want to say it.